So Mon, if I may request, please, if you could show my presentation. Each of our speakers is speaking about 30 minutes, but I'm going to shorten my presentation to only about 15 or 20 minutes to give more deference to the other speakers. And also because I'll be speaking as well in a session to, oh, there he is. Okay. So Mayor Gomez, if you can hear me, I'll get back to you after this presentation. All right, so my presentation is how indoor vertical farms foster resilience and sustainability amid pandemics and a changing climate. So at the start of this program, I mentioned about the fourth industrial revolution, where you have the convergence of the physical, the digital, and the biological. And really, vertical farming is an excellent example of an area where you have the fourth industrial revolution, innovative technologies converging together. Mayor Gomez, we're proceeding, but I'll get back to you after my presentation to ask you my questions. So please stay on. Next slide, please. So vertical farming, next slide, had its beginnings really with the space programs of the National Aeronautics and Space Administration, or NASA, in the United States. And to be fair, also with the Soviet Space Agency in the former Union of Soviet Socialist Republic, or USSR. Next slide. I had the privilege of doing my postdoc at NASA Kennedy Space Center in the 1990s through the US National Research Council postdoctoral fellowship. Next, please. And my designated unit at NASA Kennedy Space Center was Advanced Life Support Division, which really is, in simple terms, space farming. Next slide, please. So in the future, NASA is going to deploy a manned mission not only to the moon, but even on Mars. And of course, the astronauts need to survive for a long duration of time. And so the most economically feasible plan is for them to be able to grow their own food on site. And so when I was at NASA, this was in the 1990s, LEDs were just coming up in the market. And so this facility at Kennedy Space Center was still using high pressure sodium lamps. You have wheat here that's being grown hydroponically, that's in the absence of soil, using exclusively designed nutrient solution to be optimal to the growth, the yield, and the quality of the crop that's being grown. And in this case, that is wheat. And NASA has really successfully demonstrated growing all types of food crops, from cereal to salad crops, tomatoes, sweet potatoes, whatever, in hydroponic systems in a very close environment system. So this is this chamber here, we call it the biomass production chamber, was completely airtight. There was a leakage of about 0.001% in terms of air. The temperature is regulated, of course, the relative humidity is controlled, the light level is controlled, the light quality, the light period per day, and so on and so forth. So it's really tightly controlled. And so not a surprise, you're able to really maximize and optimize the productivity, as well as the yield, as well as the quality of the crops that you're growing. Next slide, please. All right, so here's another picture. They're growing lettuce. Next slide. This is potatoes that were grown hydroponically in the same demonstration biomass production chamber. Next slide, please. And again, everything is contained in a hydroponic vessel. So when I moved to the University of Arizona, after I got hired, I continued my work on space life support. And I had international collaborations, including in Japan, because the first country that really commercialized vertical farming or indoor farming was Japan. And this was actually visiting a professor, Professor Kozai, at Chiba University when I had a Japan Society for the Promotion of Science Fellowship. And they treated me with his grad students, and the grad students were partying like it was 1999. And in fact, because it was December 1999. Next slide, please. And I got invited as well by some of the pioneering vertical farming operators in Japan. This one was with Cosmo Plant, which was in Tokyo, in Narita, that is close to the international airport. Next slide. And now in 2018, 2019, the last few years, vertical farming is still thriving, particularly in Japan, as shown by these slides here. This one is the company spread, which is in Tokyo. The previous slide was a company called Mirai. And again, imagine a warehouse that is completely closed and you're growing these crops without soil, using liquid nutrient solutions. You're not dependent on sunlight. You're only providing lighting using light emitting diodes at controlled intensities and at controlled wavelengths or light qualities. So you can really optimize the productivity of these crops. And that goes to show that your production becomes independent of the weather, the climate, the location, the geography. Basically, you can do this on Earth, you can do that on Mars or on the Moon as well. It really doesn't matter. Next slide, please. And if you could do it twice. And this one is in College Station, Texas. That was iBiotherapeutics. They're growing plants, however, they're not growing the plants as crops or food, but those crops are genetically engineered so that they produce insulin. So that was really for medical application or production, or pharmaceutical production. Here's another example of the company. Next slide, please. And do it 3 times. I'm just showing you here some real companies that have commercialized vertical farming. This one is in Norway. Next, please. Even in the United States, particularly in the tri-state area, in the Northeast, New York City, New Jersey, there's a lot of vertical farms that have cropped up. That are operating commercially now. Next slide, please. And this one is in China, and China is a major player in vertical farming as well. Next slide, please. And I had a reunion with Professor Kozai 2 years ago in China. Next slide, please. And my group has been working on this particular type of vertical farm, which we refer to as the minimally structured, modular, and prefabricated vertical farm. It's like a Lego structure that is composed of uniform building blocks. And the building block could be a shipping container. Next slide, please. And you can assemble these building blocks in many possible permutations of geometric configurations. Next slide, please. So this is a demonstration shipping container that my students have retrofitted to be a unit for a vertical farm. Next slide, please. This is here at the University of Arizona in Tucson. Next slide. These are some of my students. And I'm going to show you the interior of the shipping container. Next slide. So you can see these growing structures that are generic, and some of them we have designed and we have patented, like this one we refer to as the V-Hive green box. Again, in terms of the technical details of this, I'll describe those in the session that I'll be participating in tomorrow. Next slide, please. Next slide. So I think you get the idea that we're growing plants under highly optimized and controlled environments. Next slide, please. And one more. Okay. And here's another innovation that we have developed, which is this Go Vertical Farm, which really is an automated system so that you don't need workers essentially to go into where the plants are being grown. You can just command each of these units through the robot upon which that growing system is standing or sitting. And so you can really control this remotely and the operation will stay extremely clean and free from any contamination. Next slide, please. Make it 2. Another one, please. All right, so I'd like to focus on this. I'm thankful to the Department of Science and Technology of the Philippines for approving my Balik Scientist Fellowship. Next slide, please. And of course, where else to spend that, but in a place that really bore the brunt of one of the biggest typhoons in recorded history, which is Typhoon Haiyan. Next slide, please. And of course, the center of that, the epicenter was Tacloban City in Leyte. Next slide, please. And so I'll be spending my Balik Scientist program, next slide, at Eastern Visayas State University on the invitation of their Associate Dean or Vice President, sorry, for research, Dr. Caintic, as well as the President, Dr. Dominador Aguirre. And this is through the facilitation of our PAASE colleague, Alvin Culaba at De La Salle University. Next slide, please. And the goal here is to be able to engineer resilience as well as sustainability. Next slide, please. All right, next slide, a few more. So this is ABSU, or Eastern Visayas State University. The gentleman to my left in the picture is the president, Dr. Aguirre. And of course, our PAASE colleagues, Alvin Culaba, national scientist Luli Cruz, as well as Ann Villalobos. Next slide, please. And this was in our mock city, by the way. That's big stadium last year when we had a conference. Next slide, please. And that is Dr. Caintic right there. So, of course, I realized that we've been working here in Arizona on highly sophisticated systems, which are not directly translatable or applicable to conditions in the Philippines. And so we are going to, or my intention is to be able to design and develop a frugal engineered vertical farm that would be appropriate for producers and farmers in Leyte, including in Tacloban, and hopefully in Ormoc as well. Next slide, please. And of course, we're going to be engineering this. We're going to look at the fluid dynamics of the air movements inside so that we can really regulate the temperature, humidity, and other important variables. Next slide, please. And this is particularly true, as I mentioned, because again, Leyte has become the epicenter of climate change in the Philippines and perhaps in the world. And so it's very important to provide capacity building for its farmers to be able to grow crops in a resilient, reliable, and sustainable manner so that their way of life or their work, their production is not at the mercy of the changing climate or weather. And of course, I realize as well that in Ormoc, as well as in perhaps other parts of Leyte, renewable energy is available not just in the form of solar energy, but also geothermal energy. So we could really potentially tap into this available renewable energy to make our operation really sustainable. Next slide, please. And these are some of the teams at De La Salle University in Manila who will be working with me together with Dr. Culaba. Yes, I just want to point out that one is Elmer Dadios and this one is Edwin. Next slide, please. Sibinco, sorry. And this is OG. This is Urban Greens, and this is Ralph Becker. He is a commercial operator working on vertical farming in Makati, and we will be involving him as well because we're not interested in just research and development. We want to be able to commercialize our efforts. Next slide, please. And we will be working with farmers associations in Leyte. You see, one of the features that I really like about Leyte is that they have farmers associations whose formations really were catalyzed by the governor of Leyte, Governor Petilla, and one of which is this farmers association called Villa Consuelo. Next slide, please. So this is an association of farmers. They banded together and they received help in terms of technology input, most important market linkage as facilitated by Governor Petilla, as well as help them in terms of doing a business model. Next slide, please. And that's Alex Alborita, who is the basically the CEO of these farmers associations. So they're growing high value crops, of course, outdoors. Next slide. And I was just speaking with Mr. Alburita yesterday, and he told me that they're also growing some crops in a semi-greenhouse structure, which of course is very rudimentary, like this, and like the next slide, please. So they're growing carrots, they're growing strawberry, next slide, please, and cauliflower, and a lot of these high-value crops. So they're already starting of thinking, and organic as well. They're already starting to transition into a semi-controlled environment production system. And so that's where myself as well as my collaborators at BLSU would come in terms of really providing them capacity building to develop further their indoor agriculture engineered systems. Here's another Farmers Association, La Granja. Next slide, please. Next slide, which we visited, meaning Alvin Kulaba and Luli Cruz about 2 or 3 years ago. And this is the owner and operator of the Farmers Association. Next slide, please. And of course, we visited Mayor Gomez last year in his office. And I haven't talked to him about this yet, but hopefully we can discuss having a collaboration in terms of vertical farming demonstration in Ormoc as well. Next slide, please. This is the governor, Governor Dominic Petilia, who's really very business-minded and very earnest in terms of providing capacity building for the farmers of Leyte to be able to band together into associations so that there is economy of scale, helping them with business model and helping them with linkage with the market, so that their agricultural operation really becomes economically feasible. And so that provides opportunity for these organized farmers to really grow and to really earn income and make their income grow over time. Next slide, please. So ultimately, what I'd like to explore together with EBSU and all the other stakeholders is to look into establishing an indoor agriculture innovation economic zone in Leyte. I just checked, and I think there is a PAASE initiated agro-industrial economic zone in Leyte, one in Leyte and one in Samar. And so I need to do my homework in terms of really understanding what they're currently doing and how effective it is. And so we hope to link with them so that we can establish this bustling and thriving and successful economic zone that is focused on indoor agriculture, because as the climate continues to change, particularly in the Philippines, there is more need for farmers to have that access and even the option of moving indoors to be able to have a resilient and sustainable means of crop production. Next slide, please. I believe we're approaching the end. Yes, I just want to acknowledge my grad students and visiting scholars here at the University of Arizona. We call ourselves bioimagineers because we're really using not only tools of science and technology, but our innovative imagination to be able to design really useful solutions, innovative and valuable solutions to a lot of the grand challenges that we are facing today as a community of nations on the planet. Next slide, please. And I believe the next slide is the last one. Yes. So, all right. So that is my email address if you are interested in contacting me. So thank you all very much for listening.